Welcome back to the official channel of Dr. Abdul Kalam Technical University. This is Anamika, Associate Professor, Galgodia College of Engineering and Technology. Today we are going to solve some problem as we have studied almost everything in Unit 1, that is vector operation, various kind of vector operation and coordinate system, and after that vector calculus also. So now in this lecture we will solve some problem, because problem solving is very important to learn anything conceptually. So let's start. So in this first example we are going to solve a vector, one vector A and vector B is given, and we need to find the value of a component of A along AY. Means we need to find the value of component of A along y axis. So we have to analyze the vector A. Vector A is 10ax 4ay plus 6az. As we can see that the coefficient of ay is 4, it means that the component of A along ay is simply 4. The answer is 4. Now in the second one we need to find the magnitude of 3a minus 3b. Now 3a, it means that we need to multiply the vector A with the help of we need to multiply A by a scalar 3. So A is our 3a minus b can be written as 30ax minus 12ay plus 18az. Minus b means minus b is 2ax plus ay, 2ax plus ay. So the subtraction of two vector, now this is one vector and this is another vector. Subtraction or addition will happen with similar component only. As for example, here 30ax is there, so and here 2ax, it means that the total final answer is 28ax minus 10ay. As second vector is not having any z component, we will write simply the z component of first vector, that is 18az. This is the final answer. This is how we perform addition or subtraction. Next we need to find unit vector along A plus 2b. For that, first of all we need to find the value of A plus 2b. Unit vector is nothing but a vector which is having magnitude as unity and gives the direction. So first of all let us find the value of A plus 2b. A plus 2b will be 10ax minus 4ay plus 6az plus 2b. So plus 4ax, because b is this one, 2 multiplied by 2, 4ax plus 2ay. After solving this we can get 14ax minus 2ay plus 6az. This is the final vector, that is A plus 2b. Now we need to find the unit vector. To find the unit vector we need to find the magnitude of this vector first, and magnitude of A plus 2b can be found out as root under 14 square minus 2 square, sorry, plus 2 square, that is 2 square is 4 plus 6 square, that is 36. After solving this, we can get the value of a plus 2b. And to find the value of unit vector, the formula for unit vector is equal to the magnitude vector itself divided by the magnitude. Here we are having the vector a plus 2b divided by magnitude is 14 square plus 40. Okay, so I am simplifying little bit, that is 14 ax minus 2 ay plus 6 az divided by 256 plus 40. It will be something. Means in this way we can find the value of unit vector. So now hope all of you must be familiar with the process how we can find the value of magnitude of any vector and unit vector of any vector. Let us come to the second example. In this example, the question is point P and Q are located at here and here. These two coordinates are given for P and Q, and now we need to calculate the position vector RP and distance vector from P to Q. Before solving such kind of problem, we need to locate all the point first to visualize the problem more clearly. As there are 2 points, suppose there are 2 points, here is our origin and here is point P and here is Q. The coordinate of P is given as 0, 2, 4 and the coordinate of Q is given as -3, 1 and 5. -3, 1 and 5. So there are two kind of length vector, that is there are two kind of length vector. First one is the position vector. Second one is the distance vector. Position vector is the length of a point from origin. However, distance vector is the length between 2 points. As for example, if we will calculate the distance from the origin to point P, then it will give a position vector of point P. If we will find a distance vector, a vector between origin and Q, it will give the position vector of point Q. But if we will find a distance between 2 points, that is a P and Q, then it will give the distance vector. This is the difference between position vector and distance vector. Position vector gives the idea about position of a particular point in the space. However, distance vector gives the idea about the distance between two given points. Now in bit A, we need to find position vector rp, means we need to find the vector between origin and p. It will be simply rp position vector will be equal to final point minus initial point. All the point at origin is 0, so we can simply write this. We can write this as 0, 2, 4. Also, alternatively, we can write it as the x-axis, x component is 0, so we can write it as 2ax ay plus 4az, where 2 and 4 are the coefficient or intercept on y-axis and z-axis. However, ay and az are the unit vector which shows the direction along y-axis and az shows the direction along z-axis. So, this is the position vector rp. Next, we need to find the distance vector from p and q. It means that p to q, we will draw a line between p and q. Now, the distance vector is equal to the final point minus initial point. So, the final point is minus 3, 1, 5 and initial point is 0, 2, 4. So, the distance vector pq, to represent any vector we need to put a bar over the vector. So, this is the vector pq. It can be written in two ways, that is a final point minus initial point. Final points minus initial point. Here the final point is minus 3, 1, 5. We are moving from p to q and the final point is minus 3, 1, 5. So, we will write here minus 3 and the initial point is 0. So, minus 3 minus 0 comma, second point is 1, final point is 1, initial point is 2. So, 1 minus 2 comma, final point is 5, means this is the x component of final point, this is the y component of final point, this is the z component of final point. We need to perform individually. So, now we are considering the z component of final point, that is a 5. So, 5 minus initial point, z component of initial point is 4. So, this is a 4. After simplifying, we can write it as minus 3, minus 1 and 1. This is in point form. We can represent this in a vector form also. So, PQ will be represented as minus 3 AX. It means that in vector PQ there are intercept minus 3 on AX and minus AY plus AZ. If we will draw it on coordinate system, it will look like something. Suppose this is X, Y and Z. Then as we can see that minus negative. So, we need to extend this X backward in negative direction, because in this direction this is the positive direction. So, in those direction it will be negative direction. So, here 3, we need to mark 3. Then on y axis, negative y axis, this is 1. On z axis this is 1, means our point will be somewhere here whose coordinate systems are minus 3, minus 1 and 1. In vector form we will represent it like this. Now come to the C point. Here we need to find the distance between P and Q. To find the distance between P and Q, we need to take the modulus of this vector PQ. So it will be PQ can be found out as root under 3 minus 3 square plus minus 1 square plus 1 square. After simplifying it, we will get 9 plus 1 means root under 11. So the answer of this question is root under 11, and answer of this is this one. Now come to the D bit, where we need to find the value of a vector parallel to PQ with magnitude of 10. It means that we need to find a vector parallel to PQ. Means suppose there is P and Q, means we need to find the value of a vector which is a parallel, means our destination desired vector is this one, whose magnitude is 10. The magnitude is 10. So to find this kind of vector we need to find the direction, because magnitude is already given, and any vector quantity is having two things, that is a magnitude as well as the direction. So magnitude is already given, so now we need to find the direction. And in the problem says that the desired asked vector should be parallel, means the direction of this desired vector will be same as that of the PQ. So for that we need to find the unit vector of PQ, and we know that for getting the finding the value of PQ, unit vector is nothing but the vector divided by the magnitude. So we found the vector is minus 3, minus 1 and 1. The magnitude we can find, we have found 11. So this is the unit vector. We can write it in AX and AY, and once we will find this parallel vector will be nothing but 10 multiplied by the unit vector, that is divided by root under 11, and we can write this minus 3 minus 1 as a vector as minus 3 AX minus AY plus AZ. Whatever will come after the solving this will be the answer of D bit, that is a vector parallel to magnitude 10. Means we need to find the direction, and direction is given by the unit vector. So we have found unit vector and simply multiplied with the magnitude that is given already, that is 10. Now here another vector is given, that is A and B, and we need to find the angle between A and B. In various kind of operation, vector operation, we have studied addition, subtraction, multiplication and division. We have already seen various examples of addition and subtraction. Now in this we will see the multiplication. We know that multiplications are of two types, that is a dot product or cross product. So we can solve such kind of problem using either dot product or cross product. dot product of any two vector can be defined as, this is a dot a dot b. A dot b will be equal to the magnitude of a, magnitude of b, and cosine of angle between a and b, that is cos theta, where theta is nothing but the angle between two vectors, that is a and b. So we can find the value of theta angle either by applying dot product, or we can also go for cross product. We know that the cross product of two product are two vectors are a b sin theta, where theta is the angle between a and b, where a and b are the magnitude of vector a and vector b. So as the cross product is little bit difficult as compared to dot product, so we will go for dot product. So let us perform the dot product of vector a and b. So it will be a dot b will be equal to 3 will be multiplied by 2, 3 will be multiplied by anyone will give the 0, because we know that here is the theta, cos theta, and cos 90 degree is equal to 0. So if we will multiply 3ax to any of these either by 2ay or 5az, the angle between ax and ay will be 90 degree, and angle between ax and az will be again 90 degree. So cos 90 degree is 0. So the product of 3ax with all these will be 0. So we will not consider it. Now as we know that cos 0 is 1, so we will consider the similar component. So 4ay multiplied by 2, 8, then az and 5, that is 5, it will give 3. Now individually the magnitude of a will be root under 3 square 9 plus 16 plus 1, it will be root under 26. Similarly the b value will be root under 2 square minus 5 square. After solving this we will get 4 plus 4 plus 25, it will give root under 29. Okay, so now we will apply this formula to find the angle between a and b. Cos theta will be equal to a dot b by a and b. We got the value of a dot b as 3 and the magnitude of a is 26 and magnitude of b is 29. After solving this we will get the value of cos theta, and theta can be found by taking the cos inverse of this value, that is a 3 divided by root under 26 multiplied by root under 29. Whatever the solution will come will be the final answer. Now one more important thing is there. In this example they ask to calculate the dot product of a and b. Now angle between any two vector, that is a and b, will be obtuse, right, or acute is need to know. So for that simply they are asking, do the vector from form an acute angle or right angle or obtuse angle. To know that, we need to do the dot product of two vectors, that is A dot B. After performing the dot product of these two vectors, that is A and B, we have seen that the final value is 12, which is a positive. Positive value means that the angle between A and B, suppose if this is A and this is a B, it means and A dot B is positive, it means that the angle between these two will be acute. Further, if this value will be negative, then if A dot B will be negative, then the angle between A and B will be obtuse, and if the value of A dot B will be equal to 0, then it means that both the vectors are perpendicular to each other. This is all about the concept of angle between two vectors. Now here is the three vector is given. Calculate volume of parallelepiped formed by vectors A, B and C. Three vectors are given, vector A, vector B and vector C. So, to find the volume of parallelepiped, we are usually performing scalar triple product. Scalar triple product is nothing but the dot product of one vector with the cross product of other two vectors. As for example, here we are having three vectors A, B and C. So, the scalar triple product is A dot B cross C. Means we need to take the cross product of two vectors, and the result of this will be, and after that, after having the cross product of two vectors B and C, we will do the dot product with first vector and the resultant vector of B cross C. In matrix form, determinant form, it can be written as Ax, Ay, Az, Bx, By, Bz, Cx, Cy, Cz, where Ax, Ay, Az are the coefficient of vector A, Bx, By, Bz are the coefficient of B. Similarly, Cx, Cy, Cz are the coefficients of vector C. After solving this, we can find the value of volume of parallelepiped. I am just writing it as, here we can see that the coefficient of vector A, Ax is 2, 1 and minus 2. Similarly, for B, minus 1, 3, 5, and for this 5, minus 2 and minus 2. The solution of this matrix will give the volume of parallelepiped. Now this is the last question, in which one point is given and one vector is given, and we need to express P and A in cylindrical spherical coordinate, and we also need to evaluate the P in Cartesian, cylindrical and spherical system. So we have, in the previous classes we already have discussed various formula to convert point. So here, as 3 points are given, no angles are there, it means that it indicates that the point is given in Cartesian coordinate, which is also known as rectangular coordinate. In vector transformation, we usually transform two things, that is a point transformation and vector transformation. For point transformation also there are various formula, and for vector transformation also there are various formula. So as we know that this is a point -2, 6, 3, which is given in Cartesian coordinate, it means the value of x is this much, value of y is this much, and value of z is this much. Based on this value we can find the value of rho. We need to find the value of rho phi z, because in cylindrical coordinate parameters are rho phi z. Rho is nothing but the root under x square plus y square, phi is nothing but the tan inverse y by x, and z is same as in the cylindrical coordinate and rectangular coordinate or Cartesian coordinate, both are same. So we will write z equal to z. Similarly for spherical coordinate we are using r, theta, phi to indicate any point or vector. So r can be found using x square plus y square plus z square, and then theta is nothing but the tan inverse rho by z, or we can write it as, because we know that rho is nothing but the root under x square plus y square by z. In this way we can find the value of theta. Phi is nothing but same as this, so we will use this formula only to find the value of phi, which is known as azimuthal angle, that is y tan inverse y by x. Using this formula we can transform any point from one coordinate system to another coordinate system, and to transform any vector. Now this is the vector. To transform this vector from one coordinate to other coordinate we need to use this matrix. So try to solve this problem with yourself. Hope you will be able to do this. So in this class we have solved various problems related to vector operation and coordinate system. Thank you so much. Have a safe and healthy life.